G'day and welcome to the video. In this video, we'll be covering the fourth and final part of the process to create, rig, texture, and animate a Minecraft player character for use as a vTube character. First, we'll look at how to texture our model in Blender. Then, we'll make any refinements to our model necessary for VRM export. Then, we'll create the shape keys needed to animate our character's face. Finally, we'll finalize the model and export our finished character. Here we have our working model template, complete with loop cuts, but missing the armature and only a single layer for now. This will be enough to demonstrate the principles of applying textures before we move on to the rigged dual layer model. The first step we need to do is to select our model in object mode. With the model selected, we will now go into the Material tab of the Properties editor. This is the tab represented by the quartered circle that looks a little like a beach ball. It is also the same icon as one we can choose to show how the model appears in the viewport. We will click New to add a new material to our selected objects. To begin with, we'll make sure it is a principled BSDF and give it a sensible name, like Base Layer. We'll be changing other settings soon, but for now, this is enough for what we need. We now want to click on the UV editing option from the workspace selection choices. By default, the workspace divides into two, with the UV editor on the left and the main viewport on the right. It also changes the view back to a three-dimensional angle and zooms out. We can zoom in on the UV editor so we can see and work with the space that will be filled by our skin template. And we can reset the view in the main viewport to a projection and zoom level we're more comfortable with. It will be more efficient to work in a slightly three-dimensional projection, as we'll have to be able to select and view all faces for each object that makes up our model. If your inner face for both workspaces looks different, perhaps more like this, check to ensure you're in the correct mode. A lot of the UV editor's functions disappear when the main workspace is placed in object mode. We'll use object mode to select the object we'll be texture mapping, and then edit mode to directly select the faces being mapped, and to make adjustments in the UV editor. With the object selected and back in edit mode, we ensure we have face selection. As we select the various faces associated with the object, we'll see them appear in the UV editor in line with how Blender interprets how to unwrap the object. Each of these elements is called a UV island and can be individually manipulated. If we remember from part 2 of the tutorial, one of the methods associated with texturing models with a two-dimensional image skin file is wrapping and unwrapping. It is possible to change how Blender interprets the way to unwrap an object by right-clicking and selecting UV Unwrap Faces, Unwrap. We can force it to bias even more by changing the seams used when unfolding the object. A seam is where the cuts are made to unfold the object, and we can set them by being in Edge Selection, selecting an edge where we want there to be a seam, and right-clicking and selecting UV Unwrap Faces, Mark Seam. If we want to remove a seam, we follow the same process and select Clear Seam. Because we know the Minecraft skin template doesn't quite fold up properly, we'll just stick to direct manipulation of each UV island and leave the unwrapping in this position for now. Loading in the skin reference file, we start in edit mode, then select Image, Open from the UV editor interface. With the reference image loaded, we'll ensure that Snap to Grid is on, and Increment and Absolute Snap to Grid are selected. To help us with adjusting the UV islands, we'll also add a grid overlay to see where the snapping points should go. We will set Grid, Over Image, and fixed subdivisions of 64 on each axis. This will give us a pixel level overlay for a 64 by 64 pixel reference image. We can see in the UV editor that the object should have some texture showing, but also see in the main viewport that this isn't the case. Firstly, we go into the Material tab of the Properties editor and click on the circle on the left side of Base Color. From the pop-up options, we select Image Texture from under Texture. Use the Image Selection option to select the image you want the model to be textured with. It's possible to have a different image texture from the UV reference image, which we'll make use of later on. But, for now, we'll use the skin reference template. With the image file selected and in place, we still can't see it in the main viewport, so we need to change the viewport shading selection. We select the Material Preview mode, which is the icon that matches the Materials icon in the Properties editor. You can see the model in the viewport is now rendered with a very odd texture, and one of the limbs is not textured at all. Fixing that issue is as simple as selecting the unrendered object in Object Mode and selecting the material we only recently created via the Properties editor. You can tell from the way the texture appears that the UV islands aren't oriented correctly or in the locations we need them, from what we know about the layout of the skin template. And we can also see the alpha channel, transparency, is not showing properly. Ensuring we're back in edit mode, with face selection, we select the first face, the model's actual face, that we're going to correct the texture map for. In the UV editor, select the Move function and set about moving the UV island to the front of the face and aligning the 4 vertices with each corner of the face texture. We have the texture mapped to the face, but its rotation is off. There's a couple of ways to fix this. The first, and more complex method, which is recommended with more complex shapes being textured, is to directly move the UV island vertices to match those vertices on the model. In this instance, that would mean the top left UV island vertex would be moved to the bottom left position, since that is where that part of the image map is applied to the model, and so on. The other, simpler method, which we'll use for this tutorial, is to rotate the UV island and make any fine adjustments from there. To do this, we select the entire island, press R, and then type in 270, then enter. We can see that this immediately corrects the orientation of the mapping to the model's face. We can repeat this process for each face of the object. While the template for the other faces lacks orientation guidance, we can use the actual face region as a marker and find that each of the vertical faces of the object needs the same 270-degree rotation for correct orientation. The horizontal faces, the top and bottom of each object, require a 180-degree rotation for correct orientation. This combination of 270-degree and 180-degree rotations will carry across all of the remaining model objects. By changing the image linked in the Materials section of the Properties editor to one of our high-definition skins, we can see that our mapping from the template, complete with rotations, is correct. This is the method we'll use to rapidly reskin the model once we've finished mapping the skin template regions accurately. Returning to the template image for texture, we change the model part we are texturing by going back into Object Mode and selecting the next part we're working with. Then, the process returns to Edit Mode and continues with the same process. Now, we take the process of mapping the texture template that we've just learned and apply it to our model, complete with rigging and loop cuts. If you remember from the last tutorial, our rigging process left the head second layer in place, and we'll be using that now. One issue we've encountered during the initial process was that the transparent parts of our texture appeared black. Now that we'll be incorporating a second layer in our model, we need the transparency elements to be working properly. As with most things, there are a couple of ways we can go about taking care of this, but we'll go into the shader editor, which is used to edit the materials for rendering. We're not really interested in much here, or even which rendering engine we're using, other than the node editor and the viewport immediately above it. Since we started with a principled BSDF material and linked an image for the texture, we can see in the node editor that the alpha nodes on both the image and the material have not been linked. We drag a connection between these nodes and can immediately see that the black transparency areas are now actually transparent by seeing the change in the viewport window. We can see the changes we just made in the shader editor in our Materials tab of the Properties editor. This would have been the other place to make the link change. Returning to the template file as the base color, we'll continue to work on aligning the template regions to the faces of the objects. In this case, we're completing the dual layer skin for the head of the model, complete with the updated alpha channel that we fixed with the shader editor. We'll save the model here, export it to VRM, and see what our texturing looks like. We load the model into VRoid Hub the same way we've loaded them previously. With the model loaded, there's two very glaring issues we can see that need to be addressed. The first issue is that our model seems to be stuck posing with crossed arms. The second is the odd way that the second head layer seems to be bound to other model elements. The first issue doesn't always appear, but it's a simple fix with how we pose the model in Blender before we export it. The second issue goes back to what we've been discussing about how Blender isn't sure how to handle the extra objects that are the second skin layer when rigging the base layer. We can fix it via a complicated series of weight painting approaches, but there's a much simpler method. Returning to Blender, we'll ignore all the texturing and material work while we work on the armature and model pose. We'll also delete the second head layer so we're back to a single layer model with loop cuts and rigging. Remember to set the armature to display in front and return the viewport rendering to flat, though this isn't as important. We check using the VRM flyout menu that the rigging was correctly set for our VRM model and double check the parent settings. It's not necessary to move the top of the arm bones in, but I've done it to ensure the arm objects pivot directly on that seam, much as the character does in Minecraft. If we think about the simplistic VRM humanoid model we did, as well as the natural pose of the VRM skeleton when we load it in, we'd note that they all have the same pose. If we were to load in an existing VRM character that is correctly rigged and displayed, we'd note they also have the same pose. This pose, the T-pose, is what third-party software is expecting to see when it interacts with a model. And the crossed arms pose we see with vRoidHub is it trying to move the arms from the T down to the model's side. Since the arms began at the model's side, it ends up moving them into a crossed arm pose. We select the armature and go into pose mode to do this, and the easiest way is to select the top of the upper arm bones and R, 90 or 270, enter, to rotate them into the correct position. We note that the torso deforms slightly when this happens, and this is something we will fix with weight painting later on. Personally, I find this pose a little difficult to work with, at least for the Minecraft character, and normally work with the arms down, only putting the character into the T-pose when exporting. We export the model to VRM while in this pose, and we'll see if it's had the desired effect. Back in vRoidHub, we have our crossed arm model, minus textures this time, and we now load our newly posed character. We can see straight away that this has fixed that problem, and our model moves and bends really well, thanks to our careful rigging and use of loop cuts to encourage appropriate bending. Returning to Blender, we'll correct the deformation of the torso that has happened because we moved the arms. To do this, we'll introduce the concept of weight painting, which we'll also be using later on to help correct any issues from when Blender assigned automatic weights to the armature. We'll start in object mode and select the torso, before going to edit mode to ensure we have all the vertices available to us selected. This is because weight painting is giving a weighting of how much a bone affects a given vertex in the model, from 100% influence to 0. The automatic weighting we initially assigned when creating the armature isn't too bad, but we're fine-tuning it. We then go into the weight paint mode. The torso is all blue, which indicates to us that the current bone isn't having any influence on the torso. We select which bone in the armature we want to see the relative influence for by selecting it from the drop-down list at the top of the viewport. You can see that as soon as we have selected one of the upper arm bones, we now have a color gradient on the torso, which indicates that the bone has an influence on at least some of the vertices in the torso. The color spectrum goes from blue, for no influence, through to red, for 100% influence of the bone on that part. Because we want to remove the influence of the arm bones on the torso, we change the draw setting to subtract. We then color in on the torso, clicking and dragging over the vertices that we want to remove the influence from. As this proceeds, we see the gradient on the torso go to solid blue, and we see the deformation that had taken place disappears. We continue this process and end up with a torso only impacted by the bones associated with it. We can move our attention to the arms and repeat the selection process and weight paint process to improve the deformation that takes place when the arm bones are manipulated. At the end here, we save and export the model. Importing our new model into VRoid Hub, we see that the deformation of the limbs has improved, and the torso deformation has greatly improved. Returning to Blender, we'll continue the process of fixing our model. Now, we'll work on reintroducing the second skin layer in a way that is supported by the rigging. Firstly, we'll return the model to its original stance and hide our armature, since all we're looking for is being able to manipulate the base layer objects. We'll start with the head and duplicate the head object, much as we learned to do in the previous tutorial part. We label it appropriately and set the relations to the head. We might notice while doing so that the head originally had a relation set to armature. Remembering that once we change the relation from the origin to the first layer head, the scale becomes relative to that layer, and so our second layer appears very small. Before going any further, we'll see how this new second layer and relations are impacted by the armature. Returning the armature to in front and going into pose mode, we can see that the new second layer moves in concert with the base layer and doesn't exhibit any odd bindings. This is what we've been trying to achieve. Returning to object mode, we now scale and position the second layer properly. Remembering from our previous tutorials, we want to see and manipulate both layers, so we set the viewport display of the second layer to wire. We repeat this process for the remaining parts of the model, remembering to name, set relations, and change viewport display for each object. With all the second layers in place, we see that the loop cuts were duplicated as well, and we now test the posing of the model with everything in place. It all looks really good, and now we'll start the texturing process from scratch again, given that we've solved both the crossed arms issue and the secondary layer binding issue. Remember, as we go about using the UV editor to have the snap settings and grid overlays, as well as the face rotations that we need when adjusting the UV islands. As we start applying texture to the second skin layer, we need to remember to change the viewport display setting for our second layer object from wire to textured, so we can actually see the texture we're working with. This time, when setting our alpha channel, we'll look at the difference that changing the blend mode in the material setting has. We see as we go through the various options that the edges of the transparency regions appear different, and, in the case of opaque, the transparency reverts to black. If we're sure we've been setting our alpha transparency settings correctly, and transparency still isn't working, then this particular setting should be double-checked. If you're in alpha clip blend mode, and transparency also isn't working, check the clip threshold slider isn't at 0 or 1.0. Sometimes the extreme values of this particular setting don't result in any clipping. Our next problem surfaces as we start to map textures to objects we've put loop cuts on. Unless we've been extraordinarily careful and lucky, our loops won't line up with easy to identify pixel boundaries, and so we'll get regions within the texture on the object where it appears squished or stretched. Unfortunately for the work we've done so far, the solution is to remove the loop cuts and reintroduce new ones that align with clearly defined pixel boundaries on the template. Because the torso and limbs are 12 pixels in height from the skin template, we can easily use the multiple loop cut to introduce cuts at 2, 3, or 4 pixel spacing. Or we just use the default halving of the face to give us 6 pixels, half, or 3 pixels, halved again. With some careful redesign, we recreate the torso loop cuts at 2 and 4 pixels from the bottom of the torso. For the arms, we introduce these cuts every 2 pixels. We add extra cuts here to account for the twisting that the wrist can induce in the lower arm, and to give us more fidelity when weight painting. Of course, changing these loop cuts means having to regenerate the second layer for these limbs, since they otherwise would have the old loops still. By duplicating and scaling after the base texture has been applied, it simplifies our new texture work, as it means we can move the already configured texture map over to the correct part of the template. Finally, for our legs, we set a single loop cut at midpoint to represent the knee. We have finally mapped the skin template to the correct object faces, corrected for orientation, alpha channel, its transparency, and ensured our loop cuts are appropriately spaced at integral pixel spacings. We've also checked and ensured object parentage is correct, so when we pose the model, we should see everything moving as an entity. We can see that the model poses and moves beautifully. All textures seem to be in the right spot, and nothing odd has happened to the secondary skin layers as we move the limbs. Our next big test comes as we load a variety of high-definition skins to see how they appear. If we got all our face rotations correct, the right loop cut spacing, and the right regions of the template mapped, then it should be a simple matter of loading different texture files in through the material base color setting. Because we've already linked the alpha channel correctly, each new file will also load in its own alpha channel details. We can clearly see that we got it right. All the different skins have their second layer elements in the correct location and the skins mapped correctly. We'll save and export to VRM to see what it looks like in VRoid Hub. Loading in the new file, and we now have a major problem. The model moves appropriately, but the texturing and rendering is completely wrong. Our textures look shiny and muddy at the same time, and it seems something has gone badly wrong with our alpha channel. Given that we haven't actually changed the material or render types from our earlier successful model exports, this is a very confusing result. Thankfully, the solution is quite quick and straightforward. All the way back in part 1 of the tutorial, when we were downloading the VRM Blender add-on, there was some discussion on the add-on website about the materials that should be selected when exporting to VRM. One option was to connect surfaces to a principled BSDF, which we'd done. The successful export from Blender indicated that this was viable. What other third-party software is compatible with is another concern. Our fix is to enable VRM MToon material under the VRM material option in the material tab of the properties editor. We then need to load our texture files into the correct locations and revisit the shader editor to check that the alpha channel is connected properly. We now have a material setting that will make VRoid Hub and 3Teen happy, and also stops it looking so shiny and muddy. With all of our texturing complete, we now focus on refining the weight painting associated with our new loop cuts. When doing the weight painting correction, remember that it is the base layer objects that have been associated to the armature, and so it is those that we need to be manipulating for the purposes of weight painting. If we want to reduce the impact a bone has on that limb, remember to set the paint mode to subtract. If we want to increase the impact, set it to add. With our model textured, corrected materials, balanced weightings, we're almost done. What we've done up to this point gives our character the ability to walk, run, jump, and pose. Now we're going to add the ability to look, blink, smile, and talk. We do this through the development of shape keys, which are essentially guided deformations of the model's face to display various emotions and mouth shapes for speech. Our most pressing issue is that our model doesn't have distinct facial features modeled into the head object. We'll address that issue by subdividing the character's face into a number of distinct regions and smaller subfaces that we can then group and manipulate as if they were facial features. In setting up our workspace for shape keys, we'll load a modified skin file into the UV editor. I've added an extra texture zone in an empty part of the file, which duplicates the eye colors and introduces a texture for the teeth and tongue. We will be doing most of our manipulation on the base skin layer head object, so we set the second layer to wireframe while we work. Because the original Minecraft character has an 8-pixel square face, we'll keep to that basic dimension as we work, despite working with a much higher definition skin file. We go into edit mode, then face select the face of our character. we right-click Subdivide, which divides our single 8x8 square into 4 squares of 4x4 size. Repeating this, we get 16 squares of 2x2 size. Repeating one final time, we get 64 squares, with each new subface representing a single pixel of the original character face. We can also see that this lines up neatly with the features of our model's face. We're now going to subdivide some key spaces on the face, above and below each eye, the eyebrows, and the mouth. These new spaces will be identified as distinct vertex groups to make it easier to select the vertices we'll be deforming to generate the facial expressions. We set the texture map for the mouth by 2 rows, for the teeth and tongue. With the subdivided zones at the top and bottom of the eyes, we'll move the midpoint of these subdivided zones and set the texture maps of these new skinny zones to nearby facial tones, so that we get an actual gap above and below the eyes. For textured regions that don't quite blend in neatly, we'll use the texture paint mode and blend those regions to make it neater. The face now looks reasonable, with a distinct mouth, eyes, and eyebrows. Reintroducing the textured second skin layer, and we can see that the eyes and eyebrows remain well defined, but we can no longer see the mouth. We fix the mouth problem with this particular skin by carrying out the same subdivision process as for the base layer, and then moving down selected vertices to be able to view the mouth. We're now ready to actually deform the face. If you haven't done so already, assign grouped vertices to named vertex groups. We now add our first shape key without any deformation and label it Rest, and lock it. We need to be in object mode for this to happen. This will prevent any inadvertent deletion or adjustment of the features. A rest position is considered an intermediate point that the facial features can return to or from when not being deformed for an action. In object mode, we add and label the various shape keys we're planning to introduce. As we're not introducing overly complex expressions, we'll set each one as being relative and relative to the original rest shape. Selecting the shape key we'll deform, we now go back into edit mode and start moving the various vertex groups until we have the expression we're after. Once done, if we go back into object mode, we can now select the shape key and move the slider for value to see the deformation we just introduced and see it animate. A full value of 1 is movement to the full range of deformation introduced. We now repeat this process for the various expressions we want our model to have, as well as the various mouth shapes needed for speech emulation, mainly vowel shapes. If we need some part of the second skin layer to deform at the same time, we need to ensure that it also has key shapes to correspond. We now get the model ready for export by linking our new shape keys to the VRM blend shapes from the VRM flyout menu. As we're targeting 3teen as our end vTube animation product, we need to select the VRM 0.x format. We now select a preset that we have the shape keys for and give it an appropriate name. We then scroll down to Binds and select the head mesh and the appropriate shape key. If needed, we should also select the head layer 2 mesh and the appropriate shape key from there. Because we can combine multiple shape keys at once, in order for our character to blink with both eyes, we just need to make shape keys for winking with each eye and then combining them in the blink option. We can then use the preview button to see what sort of effect our blend shapes are going to have on our character. With all our shape keys assigned and checked out, we can save and export the VRM character. And the development of our vTube character is complete. Across this set of tutorials, we went from zero knowledge of modeling and rigging a character through to generating a character suitable for vTube use. This included learning enough features of Blender to be dangerous to ourselves, learning about basic concepts of 3D modeling, being introduced to a range of third-party tools to help us develop and display our vTube character, and working our way from basic primitive VRM models through to our correctly scaled and rigged Minecraft character. We learned enough about rigging, armatures, texturing, materials, and shape keys to give us a starting point for more detailed work in the future. At the end of it, we have a model that is fully animated, complete with facial movements, and capable of supporting speech. If you've made it this far and have been able to get a similar result, well done. You've got a lot to be proud of with what you've achieved. In this final part of the tutorial, we looked at how to texture our model. Then, we made refinements to our model necessary for VRM export. Then, we created the shape keys needed to animate our character's face. Finally, we sent our vTube character live. G'day! This completes our tutorial set, and we look forward to seeing you in our other videos. See you then.